Data fabric in cloud computing as enterprise technologies. The field of big data is subject to the forces of exponential growth. As enterprises become more data-driven, they require scalable and efficient platforms that facilitate data integration across a variety of business domains. These platforms must retain a certain level of structural flexibility, while also promoting multi-domain collaboration. By employing data fabric approaches in conjunction with cloud computing and storage, enterprises can ensure that they keep up with the exponential growth of data surplus. Moreover, they can build data-driven platforms that are efficient, secure, and cost-effective at scale, effectively streamlining their abilities to process and analyze large datasets. The data fabric approach, while novel, would allow businesses to maintain steady growth and revenue in the face of rapid technological innovation, while also creating a robust data infrastructure that spans every function and domain of the enterprise. Data fabric. The exponential growth of big data has made it difficult to manage at the enterprise level. Data fabric can reduce the dimensionality of this problem by creating a unified hybrid or cloud-based data infrastructure that actively integrates various data pipelines, emerging technologies, and cloud services into one coherent platform. The design of this platform is meant to fast-track an enterprise's attempt at digital transformation. Conventionally, enterprises would encounter the following three problems during the transformative process. The development of data silos, isolated reserves of data that pertain to and are controlled by specific data departments or sectors within a business. Decision-making bottlenecks. A drastic increase in the amount of data an enterprise acquires can overwhelm its capacity to process and understand it, effectively hindering a professional's ability to make timely and efficient decisions at the enterprise level. An increase in the likelihood of cybersecurity breaches. As enterprises expand their data infrastructure, they also have to derive new ways to store and manage the data they acquire. Data fabric design. The primary purpose of data fabric is to streamline data ingestion and integration by building connections between data sources and relevant applications. If an enterprise were to adopt a multi-cloud-based architecture, it could incorporate various task-relevant cloud services from infrastructure as a service and platform as a service to software as a service, effectively cultivating a synthesized and holistic view of their data. The beauty of data fabric approaches is contained in their versatility. They recognize that different businesses may have different needs, all of which can be compounded within a unified data architecture. Nonetheless, there are 6 primary components of data fabric architecture that warrant consideration: management layer, ingestion layer, processing, orchestration, discovery, and access. Enterprise cloud computing. Cloud computing is relatively straightforward. It describes a network of remotely located and interconnected servers that help process, store, and manage data. However, cloud computing at the enterprise scale is distinctive. It is when businesses purchase cloud services from both public and private providers to increase data processing and storage capability, streamline network infrastructure, and data virtualization. There are a number of benefits to this technology at the enterprise scale. First, implementing cloud services that are offered on a pay-per-use basis provides businesses with cost-effective data management strategy. Instead of having to build their own hardware and software, businesses can partner with cloud providers and use the arsenal of data processing, management, and storage tools they offer. Potential pitfalls. Data fabric solutions in cloud computing at the enterprise level, while they offer many benefits for businesses, do possess some drawbacks. While data fabric architecture has the ability to remedy the problem of data silos, its implementation could effectively facilitate the emergence of organizational and traditional and technical silos. The presence of these silos would likely impede the process of digital transformation and force businesses to seek out costly solutions. Finally, as enterprises, their businesses will become increasingly complex. While data fabric and cloud computing can evolve alongside this complexity, they are different to implement in practice, especially as new data sources are discovered, processed, and managed.